Hello, boys and girls. So, I heard you want to learn about probabilistic robotics. Or maybe you don't, I don't know. But in either case, you want to learn about Lie algebras. Like, if you don't want to learn, it doesn't matter how much you already know about Lie algebras too. If you don't want to, become an expert on Lie algebras and Lie groups, then you have to unsubscribe right now. I mean, who are you? In this video, I will comment a little bit on a few books. I will make some half of them are recommendations from me. It starts with stuff that I actually need for work, like this thing, some probability theory. But really, I have gotten a little bit more interested recently in algebraic groups over finite degree transcendental extensions of the rational numbers. So basically, mostly linear representations of Lie group kind of objects, but a little bit more discrete, because in the spirit of this YouTube channel, right? The last months I went very much in the computational direction. So as you notice by now, this video is a little bit more of a ranty one. Similar to 3 months ago, I talked about set theory, and so there was like an exploration of my current interests and readings at the time, and this video is going to be similar. So back then, if you have not seen that video, I really recommended this book I found. It's called Sets, Functions and Measures, but it comes in 2 volumes. The first one really is just a super formal set theory book. It's more formal, I would say, than the standard Yech one. I mean, obviously this just defines formally all the concepts to do measure theory on a very logically inclined level. And so it's not like other set theory books which want to go in the direction of being able to speak about large cardinals and so on. But instead, this is just trying to be very precise with the foundations. And in a way, this channel is also developing in this kind of direction. And so, as a physicist, you are naturally drawn to semigroups, one parameter semigroups for linear evolution equations, because this is like bread and butter in many mechanics frameworks. And so eventually I want to talk a lot about these kind of exponential functions and the operators that give solutions to physical equations and so on and so forth. But for this you need a lot of functional analysis setup and background. And since I really want to more or less step by step from the very primitive things build everything up in this channel, that's kind of my accidental niche that I want to go at. You cannot really start at this Banach space level and go with these things. So something which is very grounded and very close to things that you can define early on, very without hand waving. Notions are, of course, Lie algebras, and at the same time they are extremely important for everything that moves, literally. And since I was when I introduced my virtual machine and coded up gradient descent and all these things in terms of these computer science minded notions, I got more and more interested also in mathematics over rational numbers, and for the sake of getting still closer to the things I do at work, to getting closer to formalizations from cutting edge algorithms and the math you need there. I don't want to do like, you know, number theory for number theory's sake or anything like that, or group theory for group theory's sake. And so that's why I say I'm interested now in algebraic groups. I opened very few tabs for that video. So I am not the strongest in algebraic geometry, and so that's why there's also a kind of steeper level for me. Of course, at university I had courses on, like I went to the maths department, I did Lie groups, Lie algebras, and I'm comfortable with that. But as soon as you give up all the nice, you know, closeness, compactness features, things get more tricky. And I found the literature, the standard literature on algebraic groups tend to be more broad than narrow. If anybody knows about what I said before, like finite or at least countable field extensions of the rationals and how that's used with groups that have Lie algebras, right? In this regime, I would be very much interested. So let me know. One book I recommend is this one. Multiple view geometry is like a standard when it comes to computer vision. Like it's a standard reference, and you know, this is this is what engineers also read, but nevertheless it has some, I would say, quite abstract discussions of projective geometry and so on and so forth. So one recommendation and related. Here's another nice book, and that talks about, this also comes in 2 volumes. It's called Stochastic Models, Information Theory and Lie Groups. And interestingly enough, like this is so nicely written, and at the beginning of the second book, like the first 200 pages or so, like it's really a nice, very well LaTeX typed like accumulation of descriptions and especially formulas in Lie group theory, and then it does stochastic processes and Lie groups and everything about integration and Lie groups and so on and so forth. And in this first volume, the stochastic processes on their own, and really I recommend that. But of course, this is also on the very not foundational in a sense corner in the way I use it when I talk about set theory and so on. But it's more on the practical side. But this is also another recommendation if you came across it. It's I accidentally I found that because people I know had it lying around and so on and so forth. It's not a Springer book, I think, and I've never seen it anywhere else, not in the library and so on. So it's a good find. I tried to make like kind of sense of the structure of this video. And what you know, there's different topics, they all kind of fuse together, but I didn't know where to start, and I don't want to spend too much time on figuring out how to actually structure something which has an obvious starting angle or ending angle. So now I come to if a lot of I don't really know my audience too well, because of some people who just like coder kind of guys, some people who are just logic kind of guys, some people who are hopefully more also in the physics applied direction. Nevertheless, if you have no idea what I'm talking about in this video so far, I recommend you get started with some linear algebra. Here I have 2 recommendations, Michael Artin and Lang. This one is a little bit thicker. Sorry. So and this is also more like it has more matrix calculations and more examples, and also it has a Lie group on the cover art. So I would say go with that. It's work, but we all have to work, right? I mean, I also have here like spin-off for this video, Kama Sutra, but it's not a recommendation. You should actually do that instead of that. Yeah, I asked around a little bit on the local discords, also for talking about algebraic groups, in particular for the things I'm currently interested in. There is this standard by Humphreys on algebraic groups. I forgot the exact name. I think it's called linear algebraic groups. So if you look at, there's a small glossary. And also there are some other books. I found that one in the library by Hochschild, somebody I know from from physics, from the string theory direction. It's called Basic Theory of Algebraic Groups and Lie algebras. One would think this is exactly what I wanted, but I have to be honest, it's a little bit steep, because I kind of lack the algebraic geometry to enjoy that, and so doing examples without having been shown an example is always hard. So this is not a recommendation. Also, I think I like the guy. The other books are more approachable about what I found, and this is a recommendation. And I think I was on this website before at one point. There is this website by Milne. I'm not sure if that's the right pronunciation. The guy has some photos of, I think, New Zealand or something on his website, but also like this is a guy who already wrote books in the 60s. He has a lot of lectures here on his personal webpage, and I think so far the things I've seen here look the most approachable. Like this, or maybe not this one. There's also one on Lie algebras somewhere. Yeah, I think here. That looks very nice, and I will get to that. Yeah, so very approachable. I hope. So that's a definitely recommendation. This guy has much more on his website. He also links to his articles and books and reviews of collected works of peoples and so on. And it looks like he has this website since on the internet since '96. Very great. I'm pretty sure I know the name as well. I think he has. Yeah, he definitely also has a Wikipedia page and so on. It's not a nobody, an incidental find. Anyway, I still have here the semigroups Wikipedia article as well. I would like to talk about that, but I decided to maybe motivate you guys to calculate along with me. The last two books here I have is by Hall, Lie Groups, Lie Algebras and Representations. I read that book, I think, 10 years ago, when it was very hard, not too hard because it has a lot of examples and matrices, but I surely didn't understand everything when I read it the first time, when I was still in university. But this is like I think Lang is also mostly liked for having a very clear read, even though I think Lang has maybe less examples than the Artin book. But this is a really well said LaTeX document in book form. It's very nice to read. And even more basic and simple, there's this book, Introduction to Lie algebras. I will end with the video with the name that I titled the video. This is more straightforward, more to the point. It's just about Lie algebras, so just about the tangent space of Lie groups. I was thinking maybe I should in these videos maybe give questions, like in this video already, I kind of try to get a little bit more personal, ask for recommendations, ask for opinions. And I will also in this video maybe post some examples so that people who might want to get into that can maybe look at the book, go to your library and borrow it and start reading. It's very approachable. And you can be sure if you ask some questions within months of me posting this video, I will be happy to engage with you and answer questions or listen to ideas or recommendations and so on and so forth. A few people contact me actually about my content by email, but don't write in the comments. Well, I don't know why, but I think that will change with time. So in this first introductory chapter, it's funny, if you look at any of these Lie algebra books and Lie group books, they kind of, I don't want to say steal, but they all have basically the same examples. It's literally even a sequence of presentations. I mean, it's a very clear and well structurable subject. It's a very nice algebraic kind of it suits itself for a nice first algebraic course in certain classification and proof methods. But it's really uncanny how similar all these books are. Gives the definition of what a Lie algebra is, some examples. If you're again, I don't really know what my viewership is. If you have no idea, then you could say a vast generalization of the cross product of vectors in 3D space. And if you don't know what a cross product is in 3D space, then you should unsubscribe because this channel is not for you. Subalgebras, ideals, homomorphism, algebras. So this is just 10 pages. Structure constant derivations. This hardly relates to me talking about the Weil algebra. One of my motivations also to going in this direction to kind of algebraize the calculus and structure constant, and then some of the examples. Okay, and here I since it's a Springer book, I don't want to hold the content into the camera, so I will have just to talk about the contents, but I will state two things. I liked some basic examples, and if you can get the book and then do the example and maybe discuss it with me. So there is talk about the three-dimensional complex Lie algebra, has basis vectors x, y, z, and then the most simple definition that you can think about in terms of Lie algebras. You have the Lie bracket of x and y is z, the Lie bracket of y and z is x, and the Lie bracket of z and x is y, right? So you just have Lie bracket of two of the basis vectors is the third one, and this is done for all of them. And so this is it tells you this is the complexification of the three-dimensional Lie algebra with the cross product. So if you take the cross product, consider this not as a vector space in R3, but complexify it. Add the make it a space over complex numbers. Basically, take two R3s, and then it tells you show that this Lie algebra L is isomorphic to the Lie subalgebra of the complex three-dimensional matrices consisting of all the anti-symmetric matrices. So show this isomorphism. You have the relations of the algebra in terms of Lie brackets given, and you should construct an isomorphism to this anti-symmetric matrices. I'm sure if you look at the Wikipedia page, you will find exactly the same group, and you can, if you don't get across the explicit isomorphism already, think about it if you like, and then also find an isomorphism of that with SL2C, so the special linear algebra with the commutator, of course, Lie bracket, two-dimensional and complex. Okay, and finally, I want to highlight a fact that was not in my mind, but is part of these examples. And I have also not, like Klimsing and other books, I have also not seen it in these other books. But it points out how if you have GLNF, so the matrices in n dimensions over some field F, and you consider that as a Lie algebra, then there's a subset of that which is always a subalgebra, namely, and this is like how do you construct this particular subalgebra? For any matrix S, if you consider the matrices such that the following equation holds, then this will be a subalgebra of this algebra. So the relation is that if you take any of the matrices, transpose it, and multiply it from the right with this matrix, if this is the same as minus this matrix times the original matrix, so x transpose times s equals minus s times x, if that holds, basically this says that you can basically pull this any s, like any fixed s, you pull it through x and transpose it, and I'm afraid that like describing the relations doesn't work so well as just writing it down, but I didn't want to create a text file and read from this and show you this file just for this one equation. In any case, you can get the book, and if that relation doesn't make sense in the way I just described it, look it up, and it points out how that always gives a subalgebra of the Lie algebra, which is kind of cute, and a lot of subalgebras arise in that way, and it gives some examples here too. And I played around with that a little bit. I saw that here it works with the transposition, but it should actually work with any anti-homomorphism, I think. That's cool. That's cool. So this is on the page 8 of this book. Borrow the book, or maybe this example is even on the Amazon visible pages. Get a little bit into the algebras. I will be happy to dig a little bit deeper, and eventually, in a year or so, speak about stochastic processes on Lie groups. Very pretty topic. Okay, I would say let's break it here. Subscribe to the channel. Forward it to anybody who is into stochastic models, information theory, and Lie groups. And see you soon.